Hello friends, this is Praveen and welcome to the second part of the chapter light. I have earlier uploaded the video on the light. That is the part 1. I recommend you to watch it first. So let's get started with the today's video. So first topic which we are going to cover is the spherical mirrors. What are spherical mirrors? We have learned about the plane mirrors. The plane mirrors are the just straight mirrors. And now we are going to make it a curve. So have you ever tried to play with the spoons? So there are two surfaces of the spoon. One that is bulged inside and one that is bulged outside. So when you see your face in the inner surface, you will see that your face is inverted. And when you see from the outside, you will see your face is normal, but some weird kind of images are formed. So we are going to learn about for that. So when the image is inverted, we know that it is a real image, and when it is not inverted, it is a virtual image. So how do we get a straight mirror to curved mirrors? How these curved mirrors are formed or spherical mirrors are formed? So are they first converted polished surface is then molded, or how they are formed actually? Actually they are formed from the spheres. So if we have a sphere here, and there are one in the one there are two mirrors. In one mirror we polish inner surface and the another we polish the outer surface, and we coat the silver coating, one in the inside, one from the outside and one from in the inside, which are so. And then we cut the mirrors, then we formed the spherical mirror. There are major two types of the spherical mirrors. These are concave and convex. Let's learn about them. So there are two types of mirrors. These are concave and convex. So what are concave mirrors? The concave mirrors are the mirrors which the polished surface is inside and the silver coating is outside. So this type of mirrors are this mirror is the concave mirror, and another mirror in which the silver coating is inside and the reflecting surface of the polished surface is the outside. These types of the mirrors are called the convex mirrors. So these have the two names, just like another names is when the parallel beams of light will come, it would converge it. So this is also called the converging mirror. And when the concave mirror is also known as the converging mirror, and the convex mirror, when the parallel beam of light will come, it would diverge it. They would all go in the different direction. They would meet here, but these lines would not meet. But when we imagine that when an observer would see that two diverging rays, he would see that they are meeting at some point. So they are meeting here, but they are not actually meeting. So they are diverging. So these are called the diverging mirrors. They are called the diverging mirrors. So let's learn about the terms of the what are the terms of the concave and the convex mirrors. So this is for all the mirrors, just like I am drawing concave mirror, and this is the center line. This is called the optical center, and this line which I have drawn, which is the perpendicular. So at this point it is perpendicular, is called the principal axis. So this line here is called the principal. This is called principal axis. And where we learned about, there are two different focuses for the where here the light is focusing here, but here the light it is, imagine the observer sees that its light is coming from here, so its focus is here. So focus is we can simply visualize it. This is the sphere from which this has been cut, and this, the center of this mirror, center of the sphere is the center of the curvature. This is called curvature. This is the center of the curvature, and half that length, that is the focus. So where all these light rays meet, there are just like it is here, it is in the that side, all the in the reverse side also. It would be the focus here, and it would be the center of curvature. So you can also say the center of curvature as a 2f means. So this value is, if it is x, so this value would be the 2x because it's twice. And same as here, if it would be the x, then it would be the 2x. This is true for the both the mirrors which are convex and concave mirrors. So let's learn about the first concave mirror. So now let's learn about the images formed by the convex concave mirrors. So first we will take a case and we will see how these images are formed. So first let's take, when the mirror, this is the mirror, that is, and this is the principal axis. So what will happen if the image is placed at infinity? So the object is placed at infinity. So this is f, this is 2f, this is f, and this is 2f. So when the parallel beam of light will come, it would then coming at the center, it would move like that way, and when it is perpendicular, it would move in that direction. So it would move in that direction, and this image which it is intersecting here, so the image would form here. So the image is, the position is at, the image is at focus, that is at f, when the object is at infinity. And what is the nature of the, it is formed inverted. So when an object is inverted, it is real. So it is real and inverted image. So this is an object, this is bigger, but this image is so smaller, so this image is the smaller in size or diminished. So this is diminished object, diminished image. The second is, let's take when it is placed between the infinity and the center of the curvature. So here is a image mirror. This is the principal line, principal focus axis, f, 2f, this is f and 2f. So when the image is between the, this is infinity, and between the infinity and the center of the curvature, which means it is here. So how would the image form? So when the beam would come, it would focus at a focus, and when another beam would come, just it is up, and it would go like that way and return back at the same edge because it is perpendicular from here. So the image is formed here. So what kind of images are formed? It is formed between the center. It is not at a focus also, and not at the center of the curvature. So it is between. So it is between 2f and f, which is focus. And what the image is formed? It is inverted. So it is a real and inverted images. It is an invert image, and the image is actually smaller. So it here the image is again the diminished images formed when it is placed between the infinity and the 2f. So let's take the third case, in which it is placed in the at the center of the curvature or at the 2f. So it is 2f f. This is the mirror. Here is f 2f. So what happens if the image is placed at a, so here, so the light would go parallel and be focused at the focus. So it would return back like that way, and the image when passing through the focus would hit. Now it's not perpendicular, it would move like that way. So it is intersecting here, so it would be here. So what is the where is the image formed? It is formed in the at the center of the curvature. It is at the center of curvature or at 2f, and it is again inverted, so the image is real and inverted, and now this time the image is magnified. They are both forming at the 2f, so these both images are not magnified, they are at the same size. So these are same size images, object and the images are of same size. So now let's take the fourth case, in which the image is so this is our concave mirror, this is the principal axis, f 2f f and 2f. So now take when the object is between the 2f and f, so a parallel beam of light would go and come back. When you have to draw ray diagrams, you simply take two rays. When they will intersect, the image is formed there. So the ray is going returning back, and one ray is passing through the focus. So after hitting the surface, it would be the parallel. So it would be the parallel. So it is the ray is formed here. So at the fourth scenario, in which the object is placed between the f and 2f, the when you will do the correct, the image would form at a center between the infinity and the center of the curvature. So it is between 2f and the infinity. And what is the nature of the object? This is magnified than this, so it is magnified, and this is inverted, so this image would be the real and inverted. And the fifth scenario, where we will take the image as the at the focus. So this is principal axis, focus, center of curvature, and we will take now this image here. So which image is formed when it is placed at the center? So a parallel beam is going, will converge at the focus and will go on, and when from here, now we will make the light ray going in this direction. So it is not it would be the perpendicular from here, and it would return back. So they would they are the converging rays, so they are not actually now we are not this they would are not meeting, but they are converging ray. We know that in some point of life they would meet. So this distance is at infinity, so the image formed is at infinity. If the two rays are diverging, we cannot say that these are surely will meet. We can say that they are not surely going to meet, but when the rays are converging, you can definitely say that these rays are definitely will meet at some point. And so here is these images is inverted, so these images are real and inverted and this image is magnified than this. So this image is magnified. So let's take the sixth scenario, which is the last scenario of the uh, concave mirrors. So when this image is placed at the, this is f to f, between the optic center and the between the optic center and the focus. So how, where would the image formed? So this is the image, this is going to parallel, and parallel beam of light, it would meet at the, go through focus and go on, and this would go focus and meet on, and this ray would go through that, and it would go like that way. So these both are diverging rays, so they will never meet. But an observer who is seeing from here the two diverging rays, he will think that this images is forming here. So it is coming from here, the object is here. So what is the now it is erect image. So when an object is at the erect, it is virtual. So the image is virtual, and erect, it is formed behind, that is behind the mirror. So it is formed behind the mirror, and the image is actually the, you can see image is magnified than the object. So it is magnified image. Magnified images. Now let's see what are the uses of the concave mirrors. First, concave mirrors, when you go to a scientist or ENT doctors, they uses the concave mirrors. So when the light rays are going, it would meet at a focus. So when the image is formed magnified, so when the image is formed magnified, and the ENT used to see the smaller things which are magnified. So these are uses for seeing for ENT doctors, which is ear, nose and throat doctors. And in the saving for the shaving of men, these concave mirrors are used. And also in the reflecting surface of the telescopes, the concave mirrors are used, they are used to focus and make the object look magnified. The another uses of these concave mirrors is used in the solar cookers. So what is happens in the solar cookers, the light rays comes, and we know that light ray is also a form of energy which is also heat energy. So this helps to focus the all the heat energy. So it would heat up the container which is kept here. So the light rays come, hit the surface, that get converged, and are magnified to a pot, in which the pot get heated, and our this or dish is cooked. Here in the solar cookers, we use the magnified or the big versions of the convex mirrors. So now let's move to the convex mirrors. So let's now learn about the different types of the images formed by the convex mirrors. So what are the different images formed by the convex mirrors? In our textbook, we have read that all images formed by the convex mirror is real, that is virtual and erect, and is diminished in size. Let's see that this is really the case. So let's take the scenario 1, in which the this reflecting surface is now inside, and this is f, this is 2f, this is f, and this is 2f. So when the image is placed at infinity, so it is placed at infinity, so we know that a parallel beam of rays would come, and these would be all going in the different directions, and the observer would see that they are these are originating from the focus. So this object is formed at a focus. So this is the object here, and this is the image here. So it is the, we are considering it to be formed here, but it is not actually forming. So this type of image is called virtual image, and this image is diminished. So this is formed at a focus. So now let's us learn more one more example, so that it becomes a crystal clear. And here, when this object is placed, this is the f, 2f, f, 2f, and now the image is placed between the this curvature or the pole. This is also called the pole. When the object is placed between the poles and the poles and the focus, how would the image formed? We have talked about the infinity, and we are talking about the now the least, and we have talked about the most distance we can see, and now we are talking about the least distance that we can see. So what would happen? The light would be come and go. Now it would passing through air, it would go again. So they would see that the image is, the observer would see that this image is forming at so these would see that the object is forming somewhere here. So now this is a not an inverted image, so means it is erect image, that is it is virtual and erect image. And now see, you can see this is a diminished in size. So we have conclude that all the images formed by the mirror is the real and virtual, and they are always diminished in size. And this case, the object is formed at between the this is the pole and the f, the between the f. So now let's see the uses of the convex mirrors. So now let's see where these convex mirrors are used. So we see that convex mirrors are reflecting, sir. These are diverging mirrors. So they diverge the ray of beam of light which is coming. So when they would diverge, they are covering a larger area. So which that help us to see the large amount of area. So where we have to see the large amount of areas, we use the in the rear mirrors of the vehicles, we use the convex mirrors, and in the mall surveillances of the malls, we use the convex mirrors, in which these large mirrors are formed. So what beam of light is coming, they would diverge and will help us to see the large amount of areas. So now let's learn about the uh, refraction of the light. Have you ever noticed that a stick immersed in a water appears to be bent and broken at an angle when where it enters the water? This is because of the phenomena of the refraction of the light. What is actually the refraction? The refraction is a phenomena in which the light ray passing obediently from one medium to the another with a different densities changes the direction of its path. So if we have the two mediums, this is the medium 1 and medium 2nd. This is the rare medium. Let's take an example of the air, and it is rarer medium, and here is the water, and it is the denser medium. From rarer and denser, we means the what is the amount of mass that is made in the amount that substance or the density of that. So this is a perpendicular. Let's draw this is called the perpendicular, which is normal. So normal, when what happens if a ray of light comes? So if a ray of light comes from the rarer medium, so what would it happen? It would bend. So it would not go straight, it would slightly bend and move in that direction. And if it is opposite, and so here we are taking the case, this is the medium 1 and this is the medium 2, in which now here we have is a water and here we have is a air. So this is perpendicular. So what would happen if now water ray is coming, denser, this is water from the denser medium, it is coming, instead of going here it would go here. So there are two cases, one from the air, the light ray entering from the rare to denser, and in another way the light ray entering from the denser to the rarer, denser to the rarer and rare to the denser. In the rarer to the denser medium, we see that the ray of light is bent towards the normal. From entering from the rarer to denser, it moves towards the normal, and while entering to the rarer medium, it bends away from the mirror, away from the normal. So it should move here, but it is bending away from the normal. So why this is why the reflection takes place? So we are going to learn about that, why the reflection takes place. So there is a molecules that form up the substance. So there are the substance formed it here. This example is of the air, and this is water. So what happens? We know that air travels with a different density, with a different speed in a different mediums. So what will happen if the light is coming? The air molecules would absorb the light, then emit it again, then reflect it, then emit it again. Absorb and emit, absorb and emit. So it takes some amount of time. The denser the medium, the more the time light takes to move it. So what we say is the light speed becomes decreased. So the light of the speed of the light becomes decreased. And so what would happen if it enter the water? So it would be due to there are more molecules, they would take the more amount of to absorb and more amount to again emit the light. So the speed becomes changed. And so what happens if I give a real life example of the changing speed? There is a sand ahead, and you are moving at a, there is a road. So this is the sand area here, and this is road. So when you are moving through the sand, or moving through the road, and wet amount, so you are in the car, moving in the car. So you are moving, and actually in the front of you there is a sand. So what will happen with the car? The part of the tire which touches the tire of the car which touches the sand first. So what would happen? It will would rotate in a slower speed. So there are the 2 minutes. So it is in the higher speed and it is in the lower speed. So this would take a slight turn. This is rotating fast, and this is rotating, instead of going here, it is rotating slow, and this is rotating fast. So we know that it would take a turn. And when this both tires are touching into the sand, they would move in a constant speed. So the car move in that direction. Instead of going in that direction, the car moves in that direction. The same phenomena applies to the light. We can explain this with the principle we have learned in the starting, that is the Fermat's principle of least time. What happens if you have to reach this destination and you are at here? This is the water and this is the land. You know that you can the shortest path is this straight, this is the shortest path from here is this line. This is land, and this is sea. Is really this distance shortest? So you know that you can swim slower in the water but run faster in the land. You can simply go through the perpendicular point here, and now perpendicular, because you can run faster than you swim, so you have to cover the last distance running, or less distance swimming, then more distance you are covering in the running. So you know that you can run fast. But what happens if this image is here? So he could only swim here, but you will run here, then go here. So we know that hypotenuse is shorter length. So but we have to also take the time that we are running, that do not takes more line than we are adding to the swimming. So light knows that where to take the bend and reach the shortest path. so the light bends. So just like if you are seeing a beaker in which this is filled with a water level, and you see a coin placed in that. You can see a coin placed in that. So actually it is here, but due to the light bending, you see the coin at a upper level, this. So this this is called the apparent depth, and this is all called the uh, actual depth. So this is donated by the a slash, and this is donated by the a. So the reflective index, what is the reflective index? Reflective index is a material defined as the ratio of the velocity of light in the air or the vacuum of the velocity of light in a medium. So reflective index is also called the absolute reflective index. So how you can calculate the reflective index? That is, we see the that is speed in vacuum divided by the speed in the medium. Speed in the medium. So this apparent depth is equals to c upon v. So this is how we can calculate the apparent depth. So friends, this was my part second of the chapter light. Continuing watching for the next parts. Friends, I hope that you enjoy learning with me, and at the last, thanks for watching. Have a nice day.